Last
Perfect.
talk.
Awesome. Last talk, so 30 minutes between us and whatever's waiting for you in the sponsors room there, I think. So, Nina?
Yeah, I guess I can start. So we're going to be talking about Kubeflow and Istio, a perfect match. So we're going to look at how Istio helps Kubeflow behind the scenes and its role in MLOps. So first, some introductions. I'm Nina Polshakova. I work at Solo as a software engineer. So we primarily do like Istio or Envoy-related work. I'm also on the Kubernetes release team, so doing the releases for 117 through 131. I'll be the release notes lead for 131. And then on to you, Peter.
Hey, this is me. I'm from Solo as well. My name is Peter Jausovec. I'm a principal platform advocate. And as Nina mentioned, we do application networking, Istio service mesh, API gateways, basically connecting your workloads. All right, so what are we going to talk about today? So how many of you have heard of Kubeflow first? One, two. Istio service mesh? All right, more. Anyone using Istio in production already? All right, half. All right, so more people familiar with Istio. That's good to hear. So what is Istio and why people use it? So Istio is a service mesh. It's basically an infrastructure layer that you can add to your apps. Think of retries, timeouts, circuit breakers, traffic routing, configuration for the routing. Typically, that was part of network libraries. Your applications were referencing those libraries. That's how you were using those, right? With Istio, this functionality has been pushed out of your application, pushed out of those libraries, and it's implemented in a sidecar proxy in Istio. And we'll talk about how that looks like. So why do people use Istio? Primarily for three things: to secure, connect, and monitor their applications. So for securing, mutual TLS is on by default. So mutual TLS, as compared to one-way TLS, if you go to solo.io and you see that golden padlock there, the key, that means it's a one-way TLS. Mutual TLS, it's two-way TLS. So I'm presenting a certificate, and server is presenting a certificate as well, and both of us make sure that we are who we say we are. So with Istio, you get mutual TLS automatically by default. With mutual TLS, because it depends on certificates, you also get strong identity. And once you have a strong identity for your workloads and your services, you can do things like authorization policies. Second thing is connecting your applications and your workloads. So this is traffic shifting, doing mirroring, canary deployments, fault and delay injection, doing retries and timeouts, and circuit breaking, and outlier detection, and a bunch of other stuff. And lastly, because all the traffic is flowing through the mesh, you get rich observability, you get rich metrics of everything that's coming in to your applications, as well as everything that's exiting your application. So metrics logging, and basically everything about the traffic. So let's think about examples. And in this very crude diagram, we have two machine learning workloads. We have BERT v1 and BERT v2. We'll be using BERT model as well for our demo. So let's think about what do you do, how do you access these workloads, how do you do inference, for example, right? We'll be using KServe and Kubeflow, and the way that you do inference is you call the model and you say you want to do a prediction, you send a post request to the workload, right? But how do you go about accessing these, right? This looks like this. If I show it to you like this, it's like, oh yeah, I send a request and it goes there and I get back a response, right? But in production, how do you run this, right? Like this has to be somewhere, Kubernetes cluster, VMs, wherever it is. It has to be secure, it has to be protected, it has to be exposed to the users, whoever your users are, whoever is going to be using this. And then what about if you want to do canary deployments? What if you want to do traffic splitting? What if you want to do A/B testing, right? So something's missing from this graphics here, right? So here are a couple of things about it, and I already mentioned these, like how are the workloads connecting to each other? How are they being accessed? Are they only accessed by internal workloads, thinking about same network in a Kubernetes cluster or across Kubernetes clusters? Do they need to be exposed through an ingress gateway or an API gateway? And then how do you decide where does the traffic go? Does 100% of the traffic go to V1 version, or does it go, or is there like a weighted split maybe, or you're doing A/B testing? Security, so if the workloads are to be accessed from the outside, how do you encrypt the connections? How do you authenticate the callers? How do you do user authentication? How do you authorization policies? And then lastly, metrics and traces. You want to know what's happening. You want to see what's happening. You want to get alerted if something happens that you did not expect. You want to track latency. You want to track error rates. You want to track all those things. And you want to know when something goes wrong. So all of these concerns basically fall in one of those feature buckets that Istio Mesh can help you with, right? So connecting, securing, and monitoring your workloads. So I'll hand it off to Nina, and Nina will give you an overview of the architecture.
Yes. Yeah, so let's take a step back from our dummy example and look at how Istio actually is structured. So in Istio, there's two components. There's the control plane and the data plane. So on the data plane, you see we have the Envoy proxy and the actual service. So in this case, it's our machine learning workload. So a user's traffic flows through the ingress gateway into the Kubernetes cluster, and the Envoy sidecar captures that traffic, and then we'll send it to the service A in this example. So the two parts, the control plane is what configures all the policies that we talked about. So the connectivity, the how traffic's routed, the traffic shifts. It also is responsible for doing the cert rotation for the Envoy proxy. So it establishes an identity for each Envoy proxy, and that's what enables MTLS to work in the mesh. And then so in the data plane part, the control plane isn't actually where any of the data flows. It's just where all the config lives. So in Kubernetes land, you have kubectl to create deployments and services. In Istio land, you have CRs that are custom resources that configure things like traffic routing through virtual services. And there's a tool called IstioCTL. That's a CLI tool that you can use to edit those policies, view, debug, and whatnot. So let's go back to our old machine learning model. Istio has its own ingress gateway that we can use, and part of that ingress gateway has an Envoy proxy. So the control plane is configuring that Envoy proxy in the ingress gateway to set routing rules, to do the metric collection, and also apply authorization rules. So that all happens on the ingress gateway, and then on the actual machine, on the workload that we care about, we can inject a sidecar. So there is an Envoy running as a sidecar container as part of our deployment, right? As part of the pod. So in that Envoy container, we can also enforce policies within the mesh. So you can do east-west routing, you can do metrics collection, you can do authorization policies on the server side of the machine, of the ML workload. You can configure TLS going into the cluster, authenticate users, so do external authentication with Keycloak and other integrations, and do canary deployments. So canary deployment is an easy example to visualize. So once you have Istio in place, you can do more complex traffic routing, and the way that Istio enables you to do that is the CR I mentioned. So you have a virtual service that you can define, and in this example we have 60% of traffic going to workload 1, 40% going to workload 2. You can define two different subsets and do a canary rollout that way. You can also route on more complex traffic routing examples, with matching on header matches, matching on the path, and things like that. So that's the Istio side. So what does Kubeflow do?
Yeah, so what does Kubeflow do? So Kubeflow is originally called KF serving, so Kubeflow serving. It's basically a standard model inference for basically a platform for scalable deployments and efficient scaling of ML models that runs on Kubernetes on top of Kubernetes. So people use it because it's open source. It has a standardized inference protocol. It runs in Kubernetes, which can scale very nicely. It supports pipelines, it supports notebooks if you're using Jupyter and things like that, AutoML, and then model training operators and serving. So here's a diagram on how it layers on top of your compute. So compute can be your GPU, TPU, CPU, doesn't really matter. You have different nodes in the cluster. They're connected together with Kubernetes. Kubernetes is orchestrating that. On top of that, you have Knative plus Istio layer, which is the so-called serverless layer that they have. And then KServe on top of it that supports all these different model frameworks. And you can do pre-processing, predicting, post-processing, explaining, and then monitoring the traffic that goes through. So how is KServe using Istio? So this is more of our bread and butter, right? We're curious about all the projects using Istio, and we're trying to figure out how are different projects using this. So first off, it's using it for zero trust. It's getting the strong identities with mutual TLS as well. So it's using the peer authorization policies. So all these underlined in italic text that's underlined in italics is the custom resources that are available if you've used Kubernetes. That's the YAML stuff that you write, right? Virtual services for traffic shifting. We showed a snippet of a virtual service on one of the previous slides where we did weighted traffic splits. Ingress gateways for bringing the traffic to your ML workloads. And then authorization policies for protecting your machine learning workloads and other workloads that you might have. However, there's also a lot of features that Istio has that are not used by KServe. And this is what we want to show you in this demo. We want to show you what else you could do with Istio. There's a QR code on there. If you scan it, it will take you to a GitHub repo with the demo. If you want to see the demo, or well, if you want to go through the demo yourself, you're going to see it right now. But if you want to go through it yourself, it has all the YAML, all the instructions for you to go through. All right, so hopefully everyone, font size okay in the back? It's fine, perfect. All right, so just VS Code, I have the instructions here. This is the repo. This is what you're gonna get if you go through that scanned QR code. And I have a terminal down here. I have a cluster set up already. We've done it because we know the Wi-Fi is not too good. So we have Istio installed, we have KServe installed as well, and so there's Istio, and we have some other stuff, Grafana, that we'll show later on how to show metrics and all those things. And I've already deployed this BERT model predictor. So let me scroll down and just show you what it is. It's fairly straightforward, and the BERT model is just used to classify emotions in text, right? So you send it a text, you send it a sentence, and it's gonna send you back a label of an emotion and then the probability, right, of that emotion that it detected, right? So it's using Hugging Face model. So this is where, oops, let me go quickly here. I'll quickly show code. I'm not going to show a lot of code, but I want to show you this. So this is all there is to this code. It's very simple. It's using the KServe model class. What we're doing here is we're creating this pipeline, calling it text classification, and using this specific distilled BERT model from the Hugging Face. And then we're defining the predict endpoint. And what we're doing here is we're taking in the input sentence, we're running the classifier, and then doing a prediction, and then returning the value, right? It's fairly straightforward. So I've already deployed this inference service. So notice this inference service is just referring to the Docker image that we built that I showed in this Python file. So let's try this out. I have to do port forwarding in order to be able to access my model from the outside of the cluster. So I'm doing this. Let me see if I can. Actually, let me close it here so it's going to be I'm going to open it like this. Otherwise, we're going to run out of space here.
Terminal space.
All right. Yeah, so I'm exposing the Istio Ingress Gateway on 8080 on my local host on my machine. So let me just show you the service is up and running. So it's BERT model accessible on this URL. And then we can test it. So the way I'm just going to send a curl request, setting the host to BERT model default example.com. Let's say this is your public model, right? You have, or your public DNS address. And then sending the request through localhost 8080. That's where I'm doing port forwarding, V1 models, BERT model, emotion model, and then predict endpoint and setting this input, right? So let's see if I quickly run this. And I apologize beforehand, like we're going through it very fast, but it's only because we have a lot of demos. Like it's mostly demos. Hopefully you'll enjoy this. Anyway, so we sent a request and we got back the prediction. Notice the first label that the highest scored label is joy with 99%, right? So the sentence, Istio is the best service mesh, is a joyous sentence. But then you also get the other, like anger, love, sadness, fear, surprise, and scores for those, right? So just an example thing, right? So what does KServe already have from Istio? So it has these virtual services defined to do the traffic routing. It has the gateway. It configures the gateways. And it also has the peer authentication to configure mutual TLS, right? So I think you're going to show this one, right? So I don't want to steal your thunder.
Yeah, so everything up until this point, so all the virtual services, the peer off the gateway, they're all like created by the initial like inference service that Peter applied. So all of this so far has been KServe creating things for you. But now we're going to create some Istio policies ourselves. So the first thing we're going to do is add some authorization. So the gateway that we've port forwarded has a couple labels that we can look at. So in the Istio system namespace, we have the control plane running, and we also have our Istio ingress gateway running. And the ingress gateway has the label app ingress gateway, and then Istio ingress gateway somewhere as well. So what we're going to do is we're going to create this authorization policy that is going to select the app Istio ingress gateway and allow everything that has the Istio's cool header on it. So anything that doesn't have the header shouldn't be able to reach our model. And this is like a silly example, but you can imagine using like a real like external auth service like Keycloak or OIDC. But let's apply this.
Yeah, so you could think of doing like user authentication, for example, and then getting the JOT token and then extracting some claims from it and then using those claims as part of your authorization policy.
Yep, but for now we're just going to use our header. So the first request I'm going to send doesn't have the header. So what we get is, let me scroll up, we get a 403 forbidden. So this request, again, didn't have the header, and we can't access our model anymore. But no worries, because, well, okay, we can look at the logs too. So this is denied because the authorization policy is like selecting the ingress gateway, it's applied on the ingress gateway. And if we look at the logs, we see that the 403 is getting enforced at the gateway level. Cool, okay, so then let's send the request with the header. So now we have the Istio's cool header, and we should get a 200 response. So yep. We still get our joy score back, and everything's working. So cool, so that is our basic authorization example. So now let's look at another thing you can do with Istio. So Istio, behind the scenes, Istio is configuring the Envoy proxy, and Envoy has rate limit filters that can be applied. So I'm gonna apply a simple rate limit that rate limits, if you have this API key header, you're going to be allowed 5 requests. If you don't have the API key, but you're hitting the BERT path, you get 2, and any other request has 10. So like if you're just checking the status of the model. So let's apply this config map first. Oh, I think there's extra text. Cool. And then let's apply the rate limit service. So this is from the Istio repo. This is basically just the Envoy rate limiter service. So it's going to create a deployment for the rate limit and Redis. Sorry, the Redis is for the counts. So like all the rate limit counts are going to get stored in Redis in the cluster. And then the rate limit service and deployment are also created. So then just to sanity check that they're actually running, and this demo is going to work. Yep, so, oh, look at that. Why is the rate limit?
We're at the mercy of...
I think it's not pulling the image.
I think you should delete the application.
No, I think the authorization policy wasn't deleted, I think. But I don't think that would make...
but that shouldn't, yeah.
Shouldn't
I think it's
block
not
it.
pulling the image.
We're at the mercy of the Wi-Fi, so...
Yeah, let's double check real quick. If we
Yeah,
can
but the
load it.
idea here is that what Nina did is she created that configuration, applied the configuration. Configuration is configuring the Ingress gateway, right, to point it to that rate limit service, right? So whenever a request comes in, it's going to gather and say, oh, was this on this path? Was the request on that path? Send that information to the rate limit service. Rate limit service will check the actual rate limits, and it will send back a response, either yes or no, let it through, or rate limit the service.
It looks like we're back in business. So while I apply the next Envoy filter, the rate limit service did come up. I think it just had an image pull issue, so classic Wi-Fi. So the next thing I'm doing is applying an Envoy filter. So because Istio is just configuring Envoy, you can use this advanced feature called an Envoy filter that just patches Envoy directly. So what we're going to do is add the rate limit filter to the gateway. So we're selecting, again, the app Istio Ingress gateway, and we're going to tell it to how to reach the rate limit server. So it's going to use gRPC to hit rate limit in the default namespace, and it's going to fail if the default mode is going to be a failure. And then the last thing we have to do is actually tell it what resources to send. So I have another Envoy filter that I'm going to quickly apply. And this is sending an action for if you have this header, we're going to send it to the rate limit service as an action and match on the descriptors that were defined in our config map. So the API key header that's going to see if the path is this BERT model predict path. And any other path we're also going to send. So that is it's the information that Envoy is going to collect and send to the rate limit server to actually enforce the limits. Okay, so let's send some traffic. So we're going to do the same request as before, and it should be happy the first couple times, and then we get rate limited. So we get the 429, but never fear, because we have an API key called my API key. So once I do this request, I should be able to hit the model a couple more times, but eventually I also get rate limited. Even though I'm rate limited on the predict path, I can still check the status of my model. So if I do a different path, like V1 models without the predict, I should be able to hit this and get a 200 response because that limit's set to 10, so it's slightly higher than the other paths. So you can see that we're getting our, I'll make this a little bigger. Can't. So we're getting our 200 response and not getting rate limited. Eventually, if I get to 10 requests, it does, but we're going to keep going because we're short on time. So the last thing I'm going to do is clean up the Envoy filters, and I think hand it off to you for WASM.
Yeah, I think this will be the last one, even though we have another demo in the repo that I would, you should go and check it out for sure. So a lot of functionality is already part of Istio's feature set, right? And Nina showed the Envoy filter, which is kind of like a scalpel. It's a very sharp knife, right? So you have to be very careful. You have to know what you're doing if you want to use that. But there's a less sharper knife as well, but still powerful enough thing that you can do. It's called WASM, WebAssembly, if anyone heard of WebAssembly. So what you can do is you can build functionality, I'm going to say, package them up in a WASM file, push that WASM file to an OCI supported registry, so like a Docker image, pretty much. Push it there, and then configure and tell Istio, hey, I have this WASM plugin. I want to apply it on the Istio Ingress gateway, and here's the image. Just pull it down and apply it. So what that means is you can package up functionality. You can write code in Go. You can write code in assembly script, I think, and Rust maybe, I'm not sure. But there are different languages that you can write WASM plugins in, extend the functionality, and then deploy that, package it up, and deploy it to your workload. So let's do that. I'll show you, like, once I click this and deploy it, I just want to quickly show you the code. I don't know how many of you enjoy looking at the code, but so this is how this WASM extension looks like. It just implements the standard interface from the SDK. And what we're going to do is we have the ability to run code on HTTP requests, on HTTP responses, and then do something, whatever we want to do with that data. So what we're doing is I'm getting the body, I'm parsing the predictions, and then what I'm doing is I'm creating a label with, well, I'm creating a metric named label, whatever the label value is, and then just increasing the, incrementing the counter for the highest label that has the highest score, right? So it's very, very simple, basic example. So let's do this, and I'm gonna run a couple of these. And this is just to show you the metrics that are automatically collected by the Ingress Gateway, by the proxies running in the mesh. So I'm sending a couple of them here as well. And then what I'll do is, this is gonna be a long command, but what it actually does is it just runs curl localhost 1500 stats Prometheus. That's like a standard endpoint on every Envoy proxy running in your mesh next to your workloads. And I'm just grepping for the word sad. So there you go. So we have a sadness counter with a number 6. So all the responses that I did before, right, or requests that I sent before. So we got sadness, and I think we have joy as well. So there you go. So there's a joy counter. And I just want to show all the other metrics. So this was an example of showing how you can create your own metrics if you want to, right, programmatically. But there's a lot of other metrics that Envoys capture, and then you can use to visualize in Grafana, to alert on, to do whatever you want, right? And we don't have time for that demo, but it's all in the repo, so you can go and take a look at it there. Now I'm going to go back to the slides. I think we have one more slide, right? So quickly, what's coming up? Do you want to do it?
Yeah, I can do it.
Go ahead.
Remember from the architecture side, right now everything has an Envoy injected into it, but Istio in 1.22 is going to introduce ambient mode. Well, it's coming into beta, so it has been introduced, but it's been like an early alpha feature. And what ambient mode does is it gets rid of the messy sidecar. So you don't have to inject a sidecar and restart your pod. You have like a lot of functionality for free without the sidecar. So the way that ambient works is it separates the L4 and L7 functionality into two components. You have the Z tunnel, the zero trust tunnel, which is just like a lightweight Rust-based proxy that does all the L4 policies. So it runs as a daemon set on each node, and you can do basic L4 authorization based on like service accounts, L4 routing, and get basic L4 metrics. But if you do want the L7 policies that we saw, like the authorization based on like headers, the higher level Envoy filters, you can still run an Envoy in the mesh that's tied to either the service account or a namespace, and that can do your L7 authorization, it collects L7 metrics, and does the L7 routing for you. So if a waypoint is present, the Z tunnel will send traffic to the waypoint. You'll still get the same like functionality as before, and then the traffic will go to the ML workload. But if you don't have any L7 processing to do, you can skip the waypoint, skip the Envoy, and go directly to the workload.
Yeah.
And then
all right, so quickly, some of the key takeaways, because we have only a minute left, and I know we're like, food and drinks are more important than us. So what are some key takeaways? So there's a lot of new types of workloads. I'm pretty sure at this conference, and probably any conference that you go onto this year, you're going to hear about AI, you're going to hear about machine learning, Gen AI, LLM APIs, all these things, right? So all of these new types of workloads, they're all running in the cloud, right? One thing that I want to leave with you is to don't reinvent the wheel. You're still going to have to connect, you're still going to have to secure, and you're still going to have to monitor your workloads, whether those are ML workloads, non-ML workloads, LLM APIs or standard APIs or other APIs, whatever the APIs you're using, you're still going to have to do those things. Don't reinvent the wheel with those. Pick something as Istio, for example, a service mesh, something that's proven, an API gateway that's proven, that already does that. There's no changes in how these things will be applied across those workloads, right? Also, ambient is coming soon, a beta, right, to Istio, next version, in next week or 2 weeks. And then lastly, we have an Academy website with a lot of courses that you can check out. We talk about Istio, we talk about API gateways, and show you basically how to connect, secure, and monitor your workloads. Thank you very much.
Yep.
If there's any questions, we'll be here. Feel free to ask. Thanks.